today to teach you how to sketch your algebraic function and your transcendental functions. So first, let's go with algebraic functions. So let's define algebraic functions. Algebraic functions are functions that only involves algebraic operations such as addition, subtraction, multiplication, and division, as well as fractional and rational. So since we're dealing with algebraic functions, we will also cover its subcomponents. It is linear, quadratic, radical, rational, and polynomial functions.
The first is linear functions. Linear functions are those whose graph is a straight line and has one independent variable denoted as x and dependent variable denoted as y.
So after I discuss the definition of the linear equation or the linear function, so we need it to learn how to graph it. So here are the example. So the equation is y is equal to 2x plus 8. So we need to find the value of y by changing the value of x on any real number. So we try it as denoted as x and fx. Fx is equals to the variable y. So as you can assign any number, any real number. So either it's started from 0 to 5 or -5 to +5. So I try it as -5 to +1. So we have the value of Rx, so we need it to substitute it in our equation. So if x is equals to -5, so 2 times -5 plus 8 is equals to 2, -2 I mean. Then -4 will be replaced the x, and after that its answer will be 0 by multiplying the -4 times 2 equals to -8, then -8 plus 8 equals to 0. And after that, you need to substitute again the -3 into x. So 2 times -3 is equals to -6 plus 2, I mean plus 8 is equals to -2, +2. Then -2 times 2 is equals to -4 plus 8 is equals to +8. Then 1 is +6. Then 0 is equals to +8. Then 1 is equals to +10. So at this point we have the value of Rx and Ry. So at this time we try to graph it by using the Cartesian plane. So this is a portrait of the Cartesian plane. So the horizontal line is the x, then the vertical line is the y. So the highest number of x is 5, so we need to label the x's is 1 to 5. Then the y-axis, the highest number of the y-axis is 10, so we need to label it to 10. So at this point, your Cartesian plane or your graph, is you need to be consistent on your numbers from the x-axis to y-axis. Then after that, you can plot by placing the value of the x and y. So at this point, we need to graph it from we had the value of our x and our y's, so it's time to plot from -5 to -2. So here, then -4 to +0, then -3 to +2. So at this point, then -1 to +6. Sorry, -2 rather than +4. Then -1 to +6 here. 0 to +8. Then 1 is the 10. So our graph is just like this. Sorry for the lining. Oh my god. So this is the graph look like of the linear functions. So don't forget to place arrowheads on your graph. So that's it for linear functions.
So the next one is quadratic function. So it has a general form of f of x is equals to ax squared plus bx plus c, and always remember that the graph of a quadratic function is a parabola.
So the next example is quadratic function. So our equation here is f of x is equals to 7x squared plus 3x plus 9. So we can see that it is in the form of f of x is equals to ax squared plus bx plus c. So our a here is 7, our b is 3, and our c is equals to 9. So first thing we need to do is to find the vertex of our graph. So in order for us to find the vertex of our graph, the first is we need to find its x-intercept in the formula of -b over 2a. Since our negative b, so our b is equals to 3 over 2 times a, which is equal to 7. So it is equal to negative 3 over 14. So that's our x-intercept. So in order for us to find our y-intercept, you just simply substitute the value of x, which is negative 3 over 14, to the original equation, which is this. So 7 times negative 3 over 14 squared plus 3 times negative 3 over 14 plus 9 is equals to 243 over 8, or equal to 8.69. So that's it. So our vertex is negative 3 and 14 and 8, negative 3 over 14 and 8.69. So that's our vertex. Then the next thing we need to do is to try to find a value, or try to assign a value of our x to, like this. So note that you have the freedom to choose what number you want to substitute for the x value to the original equation, so that you can get the f of x, or that is our y-intercept. So for me, I chose positive 2, 1, 0, negative 1, negative 2, and negative 3. So here it is our values for our x. So for first thing we need to do is to substitute 2 to the original equation. So 7 times 2 squared plus 3 times 2 plus 9 is equals to 43. Second, substitute the 1 to the x here. So 7 times 1 squared plus 3 times 1 plus 9 is equals to 19. Then substitute the 0 to here. So 7 times 0 squared plus 3 times 0 plus 9 is equals to 9. Then negative 1. 7 times negative 1 squared plus 3 times negative 1 plus 9 is equals to 13. Then substitute negative 2 again. So 7 times negative 2 squared plus 3 times negative 2 plus 9 is equal to 31. Then lastly, negative 3. So 7 times negative 3 squared plus 3 times negative 3 plus 9 is equals to 63. So here it is, we completed our x values with our y values, and also we already get our vertex. So the next thing we do is to plot our ordered pairs. We need to plot our vertex. So negative 3 over 14 and 8.69. So by the way, negative 3 over 14 is also equals to 0.2. Then our next ordered pair is 2 and 43. Third one, 1 and 19. 1 and 19. Next is 0 and 9. approximately here. -1 and 13. -2 and 31. And -3 and 63. So it's time for us to connect our ordered pairs. After that, don't forget to write or draw a arrowhead to indicate that there is still a value after this and after this. And so, by the way, the vertex is where our graph or our parabola meets. So here it is. So that's it. That's the graph of our function 7x squared plus 3x plus 9.
The next one is rational equations. It is defined as the quotient of polynomials in which the denominator has a degree of at least 1. Thus, there must be a variable in denominator. Note that the general form of rational equations is f of x is equals to p of x over q of x, where q of x should not be equal to 0. Radical equations. It is a radical function that contains a radical expression with the independent variable, usually denoted as x, in the radicand.
So the domain of our first function, which is f of x is equals to x squared minus 9, is x should be less than or equal to -3 and greater than or equal to +3. And for our second function, which is g of x is equals to x squared plus 9, so our domain here is you can set whatever value of x. So our domain is x is less than or equal to -infinity and +infinity. So the next thing we need to do is to plug in the values of x to our function. So to simply do that, we can have our x and y table. So for our first function, the f of x is equals to x squared minus 9. So our domain is x should be less than or equal to -3 and greater than or equal to 3. So let's start with -3. So let's start with -6, -5, -4, -3. So our 3, 4, 5, and 6. So that's our values for our x. So the next thing is to plug in this -6 to the equation here. So to do that, for example, our -6, so f of -6 is equals to square root of -6 squared minus 9. So that would be equal to 5.2. So let's put it here. So ry is equals to 5.2. So the next value is negative 5, then you can just simply put it in here. So f of negative 5 is equals to square root of negative 5 squared minus 9, or that would be equal to 4, and so on. So for negative 4, square root of negative 4 squared minus 9 is equals to 2.65. For negative 3, negative 3 squared minus 9 is equal to 0. So let's proceed to our positive x values. So let's start with positive 3. So positive 3 squared, square root of positive 3 squared minus 9 is also equal to 0. And for our 4, so square root of 4 squared minus 9 is equals to 2.65. So next is 5. So square root of 5 squared minus 9 is equals to 4. So square root of, so our next and our last value for x is 6. So square root of 6 squared minus 9, that will be equal to 5.2. So let's plot our first function, our first ordered pairs for the function f of x is equals to x squared minus 9. So the first one is negative 6 and 5.2. So negative 6 and positive 5.2. So approximately it is in here. So second quadrant. So negative 5 and 4. Second quadrant. Negative 4 and 2.65. Approximately here. Negative 3 and 0. It's here. Negative 3 and 0. For our positive values, we have positive 3 and 0. So it's first quadrant. 4 and 2.65. 4 and 2.65. So our third is 5 and 4. Last one is 6 and 5.2. 6 and 5.2. Approximately here. Then just simply connect our ordered pairs. And don't forget to put a arrowhead. And then arrowhead. So that's it for our first function. Remember that you can choose whatever the value of x you want to plug in, as long as it is equal to or less than negative 3 and equal to or greater than positive 3. So let's proceed with our second function. So for our second function, which is g of x is equals to x squared plus 9. So as we can see, our domain is, this is our domain for our second function. So it means that you can plug in whatever value of x you want to be. So for me, I chose, so for example, we start with negative 3, negative 2, negative 1, 0, 1, 2, and 3. So the next thing we need to do is to plug in the value of x x's to our second equation, which is g of x is equals to x squared plus 9. So to do that, we just simply g of negative 3 is equals to square root of negative 3 squared plus 9, and that would be equal to 4.24. So let's put it in here, 4.24. So our second value is negative 2. So we just simply plug in the value of negative 2 in here. So that would be negative 2 square root of negative 2 squared plus 9, which is equal to 3.61. So put it in here. Then the next one is negative 1. So we just simply plug in again. So g of negative 1 is equals to square root of negative 1 squared plus 9, which is equal to 3.16. So our fourth value is 0. So we just again plug in it in here. G of 0 is equals to square root of 0 squared plus 9, which is equals to positive 3. So for our fifth value of x, we have 1, positive 1. So we plug it in here. G of positive 1 is equals to square root of 1 squared plus 9, which is equal to 3.16. Then the next one is positive 2. So g of positive 2 is equals to square root of 2 squared plus 9, which is equal to 3.61. So our next one is 3. So our last one is positive 3. So g of positive 3 is equals to square root of 3 squared plus 9, which is equals to 4.24. So we already get our ordered pairs for the values of x's and the values of our y's. So the next thing we need to do is to plot our ordered pairs to our Cartesian plane. So by the way, always remember that this one is our x-intercept and this one is our y-intercept. And by the way, this is the first quadrant, which is positive and positive. So our second quadrant is negative and positive. So our third quadrant is negative and negative. So our last and fourth quadrant is positive and negative. So let's plot our ordered pairs here. So our first ordered pair is negative 3 and 4.24. So negative 3 and 4.24. So approximately it's here. Second one is negative 2 and 3.61. 3.61. Next one, negative 1 and 3.16. So next is 0 and 3, so it's here. So 1, so the next one is positive 1 and 3.16, so that would be in first quadrant. 1, positive 1 and 3.16. So next ordered pair is positive 2 and positive 3.61, so that would be in first quadrant. Positive 2 and 3.61. Next one is 3. So our last ordered pair is 3, positive 3 and positive 4.24. So still in our first quadrant. Positive 3 and 4.24. So the next thing we need to do is to just simply connect our ordered pairs. So and by the way, always remember that you should always put a arrowhead after here to indicate that there's still a value beyond that line or beyond these coordinates. So that's our graph for our functions. F of x is equals to x square root of x squared minus 9, and g of x is equals to square root of x squared plus 9. So this one is the graph for our function g of x is equals to square root of x squared plus 9. And these two here, this and this is this graph for our function f of x is equals to square root of x squared minus 9. F of x is equals to square root of x squared minus 9. So that's it.
A polynomial is a mathematical expression constructed with constants and variables using the four operations. A polynomial can be a constant, a linear, quadratic, and so on. If a polynomial is divided, it is called a rational expression. But if a polynomial has a radical sign, it is a radical expression.
So, we're done with our algebraic functions. So let's move on with our transcendental functions.
Transcendental functions. These functions cannot be expressed as the finite combination of algebraic constants and variables as well as algebraic operations. Any algebraic number raised to the power of an irrational number are transcendental numbers. In graphing parametric equations, the x and y are not given. So we must find x and we must also find y by the use of getting value, inputting values on the t. So this what will it looks. So t x and y. So the values of t, it is necessary to include its value with pi over something or pi over 2, example is pi over 2, pi over 6, pi over 3. So in my own solving, I prefer 0, pi over 6, pi over 3, pi over 2, pi 2 pi over 3, 5 pi over 6, and pi itself. So that's it. So that's my examples of values. So in order to solve for x, you must substitute the value of t into this equation. So by the use of your calculator, you substitute the value of 0 to t. So 4 plus 1 cos 2 with the value of t is equals to 0, the x is equal to 3. And then if we want to solve for y, we should substitute the value of 0 into this t and then solve in your calculators. It will result into also 3. So, and also for the next is, it is pi over 6, so just substitute the value here, pi over 6, and then calculate in your calculator. The result will be 3.5. For y, the result will be 1.27. So you should input all these values in your calculator. You will get the values
4.5, 5, 4.5, 3.5, and 3.
in your y. If you put all these values, substitute all these values into this, you will get
1.27, 3, 4.73, 4.73,
t is equals to pi, then your y will be equals to 3. So note that when inputting these values on your calculator, the mode must be set to radian mode. So we have now values for x, and we have also values for y. So we can now plot the points on the graph. So first is the first value, x is equals to 3 and y is equals to 3. So here positive 3 and positive 3 y. So 1, 2, 2, 2, 2. So the point will be located here. And then next is 3.5. The value of x is 3.5, and then its y is 1.27. So 3.5 and then 1.27 approximately here. So it will be located near here. And then the next point is located at 4.5 and 1.27. So 4.5 and also 1.27 straight, so it will be, the point will be located here. And then the next is 5 and 3. So 5 and then 3, the next point is located here. Then the next value 4.5 and 4.73, 4.5 and then 4.73 approximate. So the fifth point is here, and then the last is 3 and y is equals to 3. So here is 3 and no, there would be 3.5 pa. So 3.5 is located here, and 4.73. So 3.5 and 4.73. The last point will be located here. So the last, if t is pi is equals to pi, then its x is equals to 3 and y is equals to 3. The point will go back to the first point. So let's connect the dots. So the sketch is an oblong or oval which is located to the first quadrant of the Cartesian plane. So since we are finding the motion or the path of the particle whose motion is described by the parametric equations or curve. From the first, we will determine the flow of motion of this parametric equation. So first, we started at x equals to 3 and y is equals to 3, which is here, and then followed by 3.5.1.7. So the flow is like this. And then that is how you sketch the motion of a parametric curve. So it is example of transcendental functions.
Trigonometric equation. It is a function of an angle expressed as the ratio of two of the side of right triangle that contains the angle sine, cosine, tangent, cotangent, secant, or cosecant.
Inverse trigonometric equation, also called as Arcus functions or anti-trigonometric functions. They are inverse of functions of the sine, cosine, tangent, cotangent, secant, and cosecant functions. They are also obtain an angle from any angles of trigonometric ratios.
Exponential functions. In this, you will be dealing with functions such as g of x equals 2 to the power of x, where the base is a fixed number and the power is the variable.
Logarithmic functions. Logarithmic functions are the inverse of the exponential functions. It implies the laws of logarithm. If a raised to b is equals to c, then log base a of c is equals to b.
So now let's move on to our logarithmic function. So in this example, we're given by a y is equal to logarithmic base 6x. So in this case, we can convert it in an exponential equation. It's like this: 6 to the power of y equals to x. These two equations are similar because logarithmic it explains that y is the power of 6 when the 6 to the power of y is equal to x. That's why they are similar. Then to graph it, you need to let's make a table to plot the points x and y. So since we will be using this equation, our independent variable will be y and our dependent variable will be x. So we will be the one to give the value of y. So we choose the numbers that can give us a much easier value of x. So let's say, for example, -2, -1, 0, 1, and 2. So let's substitute the value of y to this equation. So 6 to the power of -2 is equal to 1 over 36. And then this value, 6 to the power of -1 is 1 over 6. Then 6 to the power of 0 is 1. And 1 and 6 to the power of 1 is of course 6. And last, 6 to the power of 2 is 36. So by the use of this pair, we can plot the graph. So let's start.
So this is our y-axis and x-axis. So the points are negative 2 by 36. 1 over 36. So 1 over 36 is much could be in this section. So negative 2 and 0.02. This one here. And then negative 1, 1, 6. Negative 1 and 1, 6. It will be here in this section. And 0 and 1. So 0 and 1. And then 1 is to 6. And 2 is 2 is 36 to 36. So 2 is 36. So let's connect the dots. And label each, sorry, negative 2. Then 1 is to 6 and 2 is to 36. So as you can see, as you lower the value of y, it go much closer to 0, but it would not really touch as 0. And if you increases the value of y, it will go to the other side. So that's how you graph a logarithmic function.